You see the screen? Hello? Hello?
Yes, sir.
Okay, thank you. Today is a seminar, the presentation of some group. I told you last week, but the last time I have not yet finished the algorithm of the for the streamline simplex method. Streamline simplex algorithm for the transposition problem. So now let me have about half an hour to finish this, and then we start the seminar. The algorithm is this. Here is this. We call it the streamlined simplex method for the transportation problem. And today is May 6th. I give you. I just finished marking your class and of the midterm. You see, it is okay. Very sorry, that's not really good. Not good. But I will add to each of you 10 marks before upload it to the university. So your mark is equal to the mark I send it to you and plus 10. Okay. Suppose that if you have 80, then it become 90. You have 85, then become 95, something like this. All of you plus 10. That's good news. Okay. Just wait a minute. Okay. So once again, sorry for the delay, and I don't know. Okay, some of you say thank you, no problem. Today I have something very important, and come back just some minutes before the class. So it feels so tired. So I need about 15 minutes to relax, to take a rest. So tired. Okay, so we start our class. It's like the streamline method. You see the streamlined simplex method is actually simplex method. Simplex method for the linear programming. Is that okay? But so it's the same like a simplex method, but it's something like a the translation of the simplex method to the transportation problem. And so for the algorithm, first of all, you need to have at least one feasible solution first. First of all, you have to find out one feasible solution. Okay, suppose that you have X is a feasible solution, basic feasible solution. Basic feasible solution, how you find it? You can find it by the northwest corner, least cost by table, something like this. Okay. And when you have the X is a basic feasible solution, and then you have a GX. GX is a set of all selected cells of X. Is that okay? We have it, all of it, and GX here. And then we start the algorithm. The algorithm, step 1, is compute the dual variable ui and vj. You know how to compute it, is that okay? Ui and vj. Example, we should take an example. I remind you again about the way how to calculate here. For example, here, this is the right number. That is an example. The right number here are the feasible solution. Is that okay? The feasible solution here we have, for example, x11 is 80, x12 is 20, x22 is 120, x23 is 80, x23 is 80, x33 is 20, x34 is 80, and all the other xij are equal to 0. Is that okay? That is feasible. And the setup, after having this one, we defined the set gx. So what is gx? Gx is a set of selected cell. The selected cell here is what? This cell, the cell with the right number. That's all. It is 1, 1, 1, 2, 2, 2, 2, 3, and so on. Is that okay? 2, 3, and here is 3, 3, 3, 4. Okay, that's GX. That's the first thing. The first step, calculate UI and VJ. And I tell you that U1, that is U here, and that is U1. U1 equals 0. Okay? And so in order to compute UI and VJ, how do you do? We do like this. Last time I tell you, we make it very in details, but now I just want to repeat. With the ij belong to gx, is that okay? Then you have Cij equal ui plus vj. Is that okay? So look at this one. The Cij is 2. Is that okay? 2 here equal u1 plus v1 here. So what is v1? v1 must be 2. Is that okay? And here to the number 20 here, that is number 5 equals 0 and then plus 5. Okay, and here you come to the number 4, to this cell. That okay? So this cell's 4 is equal to 5 plus something here. So this should be minus 1. Is that okay? You have this. And then you come to the here, to this cell. This cell is, you see here, number C. Here is it is a 3. 3 equal minus 1 and then plus 4. Is that okay? So you have, and now you come to this. Now you come to this 20. Here number 4, that is equal to 4 plus 0. Is that okay? And here you come to the last thing is number 5 here. 5 equals 0, 0 here plus 5. So by this way you have all the UI and VJ. Is that okay? You see, very easy to find out the UI and VJ. That's right. So the first step, find out UI and VJ. The second step, find C bar IJ. Take a look. The second step here. The second step here. Compute reduced cost. C bar IJ equals CIJ minus UI minus VJ for all IJ does not belong to GX. Okay, so now we need to calculate for this one. So I have to delete all of the number here. I think all things here. So we have UI VJ. That okay? And here. Step 2. The first thing is calculate for all IJ does not belong to GX. Is that okay? So which one does not belong to GX? You have how many? You have these cells, this cell, this cell, this cell, this cell, these cells. How many cells does not belong to GX? So you have 6. Is that okay? 6. 6 cells does not belong to GX. So you need to calculate what? You need to calculate C bar 1, 3, C bar 1, 4, C bar 2, 1, and 2, C bar 2, 1. And we okay. And I'll write out here. C bar 2, 1, C bar 2, 4. C bar 3, 1, C bar 3, 2. So we need to calculate 6. Is that okay? So C1, C bar 1, 3, this one. Look at this one. C bar 1, 3 equal what? Equals C bar C1, 3 minus U1 minus V3. Is that okay? So how do you calculate that? Very easy. Take a look. If you so at this number, I will write down C bar 1, 3 here. This C bar 1, 3 equal what? It equal to C1, 3 minus U1 minus V3. Is that okay? Very easy. 4 minus 4 minus this minus 0. Then it is 0. Is that okay? Now, C bar 1, 4. This one. This number, C bar 1, 4. Is equal to C1, 4. C1, 4 is here. You see? Equal to C14 is here, minus U1 minus V4. Is that okay? So 6 minus 0 minus 5, then it is 1. You can calculate other very easy. So what is it? This is C bar, this. It is equal to 8 minus up minus 1 minus 5. So 8 minus 5 is 3, minus up minus 1 is 4. Is that okay? So what is this? This equal to, very easy. This, what is it number? 1 minus 0 minus 5. So 1 minus 5 is minus 4. Is that okay? And what number more? One more. What is more? This number equal what? Who can tell me what is it number here? C bar 2, 1. What is it? This is equal 8 minus 2 and minus of minus 1. 8 minus 2 is 6. Minus 1 is 7. Okay, what is it number? What is it number? That is C bar 3, 1. Equal what? Who can tell me? C bar 3, 1 is, hello? C bar 3, 1 equal what? Bùi Tố Mai. Okay, Họ Thương. Okay. Họ Thương. You want to say?
No, dạ con bấm lụng nút thầy.
But you can tell me what is this number? This is C bar what? 3, 1 equal to C31 minus U3 minus V1. Can you calculate? What is C bar 31? It is 5.
5 minus 0.
Minus 0.
Minus 2.
Then it's equal to
3.
3. That's all.
Yeah.
Very easy.
Yes.
So you see, we can calculate very easy, like this. And then now what do we have after all? Just a moment. I delete all things here, and then we can we see here what 1, 3. C bar 1, 3 is 0. C bar 1, 4 is 1. C bar 2, 1 is 7. And then you have here C bar 1, 2, 1, 2, 4. C bar 2, 4 is 4. C bar 3, 1 is 3. And C bar 3, 2 is minus 4. Is that okay? So all this is for all ij. For all ij does not belong to Gx. You calculate C bar ij by this formula, and then you get this. Is that okay? And among these things, there is only one. If all are greater than 0 or equal 0, look, take a look at the step 2 here. You calculate all C bar ij, and then okay. If all ij does not belong to Gx, you have always all C bar ij is greater than 0, then this is an optimal solution, and then we stop here. But in our case, is it we are in this case? No. We are in the case that there is some Cij which C bar ij is negative. Is that okay? And then by this step, by step 2, what do? Choose xij is an entering variable. Choose xij, the xij with the c bar ij is less than 0. Less than 0, then the last time you know if c bar ij less than 0, then what we have here. Here. Suppose here, you know that suppose that c bar ij, if there is some c bar ij, then that means that at the cell ij, if you because ij here, ij here does not belong to gx, so that means that xij at that time is equal to 0 because it is not a selected cell. Is that okay? It's equal to 0. But when c bar ij, that the reduced cost at the cell ij is negative, so that means that if you put 1 unit to that cells, that means that it's not 0. If you just give it ij is 1, then the cost will be reduced the amount c bar ij. Is that okay? So in that case, we have to find out the excuse me, that's very sorry. For example, it because the last time we considered this already, and you know that look, take a look here. That's c bar here. We have c bar 32 is negative. Is that okay? Let I delete all this and then I just a moment. Do you see that in this case, how can we do? What do we do? Here. So you see here in this case, you see here the corner here, the number in the corner top right is a c bar ij. Is that okay? And you have c bar ij, c bar 2, 2, 3, 3, 3, 2. C bar 3, 2 here is minus 4. It's negative. So it means that if you then we choose this cell is entering variable, entering cell. We choose this is entering cell. Is that okay? We put it into GX. And so you take a look. We forget everything. We forget everything else. Yeah. You see, if you put this is the entering cell. You make this cell, you put this cell is terrible. You put this cell enter. Is that okay? To the setup selected cell. So you see that the selected cell is the red one. And if you put one more here, that is with c bar ij is negative. And then it will create for you a cycle. You see, where is the cycle? This, 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 and this. Is that okay? And the cell you enter, you say you put the plus sign, minus, plus, and then minus. Is that okay? And you know that in this cycle, because the C bar ij, C bar 32 is minus 4. So that means that here at the beginning, you remember, at the beginning, the Xij, let me delete this one so I can write down something here for you to see. Here. It means that at the beginning, you have x 3, 2 equals 0. Is that okay? At the beginning, you have this. But now, forget this one. You see, if you put 1 here, if you move 1 unit to this, and then the cost will reduce 4 units. If you move 2 here, then the cost will reduce 2 times of minus 4, 8. If you move 3, and then the cost will reduce 12. And so you try to reduce as much as possible. But at the last time, we calculate we cannot move as much as possible. We cannot move as much as possible like that. But we only can move with the amount theta star. Theta star equal to the minimum of xij with ij belong to the B minus. B minus means the xij in the minus sign here. See? So we with this one, with the cycle, when we take this as cycle, and then you have a cycle, you call it cycle. The cycle X, I don't know the last time what when we the cycle GX, and then IJ, and IJ here is 32. Yeah, this is the cycle GX, and then 32. The cycle here, this cycle divided into 2 sets. You have the set B plus and B minus. B plus are the set of the plus sign, plus sign, plus sign. See? So B plus is B plus equal, you can write that plus somewhere, plus here is equal to what? 3, 2, and then 2, 3. 3, 2, and then 2, 3. 2, 3. And minus are the sum minus here. And you take it is the minimum of the minus. The minimum of the minus, you see the 2 minus here is 120 and 20. So the minimum of this is equal to 20. So you take the theta star is 20. And you take, and how can we do in this case? We enter here what? We will take here x32 equal theta star and equal 20. Yeah? You put that one equal 20. So what does it mean? It means that in this case, if you move to this, the maximum possible 20, then what? The cost will reduce. 20 multiplied by minus 4 is 80. Okay? The cost will reduce 80. But if you put here 20, and then what do you do? Here in the minus sign, minus 20, minus 20, and in the plus sign, plus 20. Is that okay? So what is the new one? The new one will be like this. Here, this is negative, so the plus sign. and you put here theta star is 20, and here minus 20, here plus 20, and here minus 20. And after all, you have what? This is 20, and here is 100, and here is 100, and here is 0. This is become 0, so this is living cell. And of course, it is because C bar 32 is minus 4 negative, and then this cell is entering cell. Is that okay? And then what is the new the update tree, the update cell table? The update table is here. This here, 100, 120, and then this is living cell already. Is that okay? Then you have a new feasible solution, and that's the way that we realize it. But so now we come back to the algorithm. You see, if you have C bar ij less than 0, then Sij, of course, is entering variable, and we go to step 3. Is that okay? What is step 3? Step 3 is here. Construct the cycle C bar ij. So that means in our example, that C gx, that's 32. Is that okay? And determine the set C plus and C minus. I write out there B plus and C plus. C plus and C minus are the set of all C plus are the set of all cell with the plus sign, and C minus are the cell with the minus sign. Is that okay? The cell of minus sign. And you let theta star is the minimum of xjk, KL with KL belong to C minus. And that you remember, I make it theta star equal to the minimum of Ij belong to C minus. And it is what? It is a minimum of 120 and 20. Is that okay? And that is equal to 20. So you choose the XUV, which is theta star. That is equal to what? That is U, in the example, I don't remember exactly, but this is UX33. It is equal to X33. And then you have 33 is a living. So XUV here, and UV is a living variable, living cell. And then you go to, you know that we have make that. Is that okay? Then we go to step 4. Step 4 means that we update the BF solution. Is that okay? The new feasible solution is this. The all the KL in the plus cell plus theta star. All this in the minus C minus this, and all the others which is not in C in the C plus or C minus keep the same. Okay. And so we have the new selected cell. We have the X bar is a new BF solution, and GX bar is a new GX solution by the new set of selected cells is equal to the selected cell, and delete it is a living cell, and that is the entering cell, and we put this, and then we delete this one, and we put this one, and then that means that we have here, for example, in this case, you see here minus theta, the minus theta, and then plus theta, but theta is theta here is theta star. It's equal to 20, and so you have this is, so that means that we have here minus 20 plus 20 minus 20 plus 20. So you have here 20, and here is 100. Here is 100, and then here is 0. There is 0 here. So you see the red row, that's the living cell. Living cell or living variable. Is that okay? And now you update, this is the updated, BF solution. I delete all the things I write down here. So you see, this is the updated BF solution. The O1, you remember the O1, you have what? The O1 here is 120, and here is 80. Here is 20, here is 0. Is that okay? That's the O1. And now the new one is this. Is that okay? So you come to the new BF solution. And we finish when we come to the update that's, and then we finish or complete the first iteration. Not okay? And now we start the second iteration. Do the same thing. Step 1. The second iteration. Step 1. UI and VJ. Is that okay? Find out UI and VJ. Step 1. Here's step 1. You remember step 1. And step 2 is for this. Calculate the C bar IJ is step 2. Step 1. Take a look. Here. U, that is U. U1 is 0. And from here you have here, that is 2. Then this should be 2 minus 0. 2 is 0 plus something here. Plus something here. This should be 2. Is that okay? And then that is, oh my God, that's so small. Here. 5 equals, oh my God. Here. You have a U1 is 0. Is that okay? And here is 2 equal 0 plus something here. So this should be 2. Is that okay? So V1 is 2. V1 equal 2. And that is a V2. Suppose that we have this. So we try to calculate this number. Okay. So here. 5 equals 0 plus 5. Okay. And here. 4 equal 5 plus what? Minus 1. Is that okay? And then 3 equal something here plus minus 1. What is it? 4 plus minus 1 is that. And you have something more here. 1 equal 5 plus what? Minus 4. Is that okay? But you have here 5 equal minus 4 plus what? 9. 9 plus minus 4 is 5. And so that's all. So you have V1 is 2, V2 is 5, V3 is 4, V4 is 9. Is that okay? And here, that is a U1. Is this? U1 is 0, U2 is minus 1, and U3 is minus 4. Is that okay? Is that okay? You understand? Hello? Nguyễn Anh Thư. Okay. Oh, okay, Hạ Uyên. Okay, Hạ Uyên. How Ying, you understand?
Yes, yes, I get it until now.
Okay, Anh Thư, you understand?
Yes, I understand.
Okay, so now I delete all the things I write out there. So take a look at this one, and now we calculate the step 2. Step 2, we first of all we calculate C bar ij. For ij does not, you calculate all of this based on ij belong to gx. Is that okay? And now we calculate C bar with C bar ij with ij does not belong to gx. So which does not belong to cx. So you calculate what? Look at here. We calculate this does not belong to gx, does not belong to gx, does not belong, this does not belong. Is that okay? For example, the formula is what? C bar ij is equal to Cij minus Ui minus Vj. How you realize here? For example, this is what? This is C bar 21 equal to C21 minus U2 minus V1. But you can calculate directly on this table, very easy. Okay, so I tell you, how can you calculate this? C bar 21 is equal to CG1 is here. Is that okay? This minus this number minus this number, then it's equal 1. 8 minus 2 is 6, and minus of minus 1, then it is what? It is what? Anh Thư, can you tell me what is the number here?
The number is 1.
No. Look. 8 minus 2 equal
7. 7.
okay. 8 minus 2 is 6. 6 minus 1 is 7. Okay. So can you continue telling me what is it number? It is what? It is 5 minus this minus this. 5 minus 2 is 3. 3 minus of minus 4 is
7.
still 7. Is that okay? Still 7. You can calculate another one. For example, this number is what? This is C bar 1 3 equal what?
It's equal to 4 minus 0 minus 4, so it's equal to 0.
0. That's okay. 4 is minus 0 minus 4. That's okay. And what is the number? Let me delete several things there, and then I ask you. Okay. Then I ask you this. Oh my God. This number. What is it number? It is 6. That is 6. That is 6.
6.
Minus 0 minus 9. Is that right?
Yes, it is equal to minus 3.
Minus 3. And this number 8 minus
9 and
minus 9
1 is equal to 0.
0. Is that okay? And this number is what? It is
equal to 4.
4 minus
4 and
minus 4
is equal to 4.
Okay, plus 4. So in all for all the C bar ij here, all C bar ij with ij not there is any ij with C bar ij is negative. You have what? Which one is negative? C bar of C bar what? This one is negative. See?
For 1. 1 4, 1 4.
1 4. C bar 1 4 is equal to minus 3 is negative. So what can you say? In this case, 1 4 is entering variable or entering cells. Is that okay? That is entering cell. And you have to determine. In this case, we have determined C of Gx and 1 4. What is it? Take a look. Okay, I delete all the others to make the table clear. Just let that one. That is negative. Is that okay? That one is entering. It is okay. Right down here. This is entering cell. If it is entering cell, I put it here. Is that okay? This entering cell here. And then it will create for you a cycle. So who can tell me the cycle now? Hà Uyên, can you tell me what is the cycle now? Cycle is what? What is a cycle? 1 4. That is the first cell. The second cell is what? The cycle. Tell me the cycle. One 4. The first cell. The second cell is what? Very easy. It is here. The second cell is 1 2. Is that right, Hà Uyên?
Yes, I think so. And
the next one is
next is 3 2.
3 2. Come here. And then the last one is here.
And 3 4.
Okay. And that we have the cycle. Is that okay? And then this one is entering. We mark with the plus sign. Here is minus, and here is the plus. Here is the minus. Is that okay? Remember what we don't care about this. You know, we don't care about the cell 2 2. No, forget it. We go from this one to this one. Okay. And so we have C plus. What's C plus? And C minus. You see, C minus including the 2 cell. For example, C minus including the 2 cell 1 2. And then this is what? 3 1 2 3 4 3 4. That is C minus, and C plus have the 2 cell with the plus sign. You say I don't want to write down, so we have a so small space. And then what will you do next? You find out the cycle. We establish the in the step 2. What do you do? In the step 2, what do you do? You calculate the first. Calculate this one. The second, you choose which one is negative. Is that okay? If there is some negative, choose negative. And then you conclude that this cell is entering cell. And then you establish the cycle. Is that okay? Establish the cycle, and then what do you do next? You determine the C plus and C minus. Is that okay? And then what do you do next? Step 2. Let me. Step 2. I'll come back to the step 2. here. C bar ij and xij entering variable, and then we go to step 2, step 3, sorry, step 3 is here. Sorry. So this an entering cell. This is the step 2. Step 2 until now. That okay? You see step 2. I repeat again. Step 2 is calculate C bar ij for ij does not belong to G. Find out C bar ij negative, and this is the entering cell. And go to the step 3. Step 3. Step 3, establish this one, and then find out C minus C plus, and then you do what? What next? You find out the theta star. Theta star equal to the infimum of the xij in the cell, in the minor cell. So you have in the minor cell, you have here what? 20 and 80. Minimum of 20 and 80. And of course it is equal to 20. And 20 equal what? 20 equal to this one. X what? Can you tell me? X1.
X12.
X12. So this cell will be the living cell. Is that okay? Living cell. And now you calculate the plus minus theta star, and then you find out the new xij. What is the new xij? The living cell. The theta star is 20. So in the plus 20. Yes, so here 20. Plus 20. So 20 plus 20. Minus is minus 20. Minus 20. Here minus 20. Then that is so. And now you come to the updated the problem. Is that okay? Updated feasible solution. Step 4, go to the updated the feasible solution. So what is the updated feasible solution? Updated feasible solution now. This one becomes 0. Is that okay? This is what? 40. This is what? 60. This is 20. Is that okay? So the new one will be everything else is the same, but here x12 is 0. x32 is become 40. At the beginning is 20, now is 40. And that is at the beginning is 80, now it's become 60. And that is the beginning is 0, now become 20. And now you have the updated tree is somewhere here. No. Where is it? 100, and then here, that's here. You see, the cycle is here. Is that okay? And the plus sign, minus, and then you calculate that it's 20, then it is 20, 20, 20. And now this becomes 0. This become 20, and this become 60. And this become 40. Is that okay? And you have the new feasible solution is here. Is that okay? This is in the previous BF solution is 0. 0 become 20. 80 becomes 60. That is 20 here become 40. and this is 20 and now become 0. Is that okay? And 0 means leave-in variable. Leave-in variable means outside. Okay. And that is a update table. That is the update tableau. Is that okay? And so update tableau, then you have we have a new BF solution. Is that okay? And with the new BF solution, you can start the iteration. Iteration 3. Is that okay? Suppose that you don't have anything here. Have everything here. U1 is 0. Is that okay? And now you can terrible. A lot of message. Who can tell me? Who can tell me now? We find out iteration, the step 1. UI and VJ. So can you tell me what is UI and VJ here? U1 is 0. Okay. So with this cells, you have 2 here, and then here is what? V1 is what? V1 is
-2.
no. It is Cij equal Ui plus Vj. Is that okay? So here C11. C11 equal U1 plus V1. And U1 is 0. So V1 is?
2.
Is 2. Is that okay? And we find out which next one we have to find out. We go to which cell?
3, 4.
3, 1, 4. Okay. We come to this. And then we have 6. And here, what is it? It should be 6.
6.
Okay. And then we come to what cell? What cell we should go to?
3, 4.
3, 4. We should come to this. Exactly. We should come to this. 3, 4. And that is 5. 5 equals 6 plus what? Here is?
+1.
No.
-1.
Minus 1.
-1.
Minus 1. And you know this. And then which cell we should go to?
Row 3 and column 2.
Okay, we come to this. Now we should come to this. So number 1 equal -1 plus what?
2.
2. That's right. And now we should come to which cell? We have something here, we have something here. So which cell? 2. What? We should
2.
2. We should come to this. And then 4 equal 2 plus something here. So this should be 2. Is that okay? And now, in order to calculate this one, we go to what cell? 2.
Cell 2, 3.
2, 3. Okay, 2, 3. And we have a 3 here equal 2 plus what? 3 here equal 2 plus 1. Is that okay? And so by this way, you see, you have V1 is 2, V2 is 2, V3 is 1, V4 is 6, U1 is 0, U2 is 2, U3 is -1. So all UIVJ are calculated. And that finishes step 1. And now we come to step 2. Is that okay? Just like that. We do continue. And now with the step 2, what do? Now I delete all these things so that you can see. We have a UIVJ there already. That's okay. And now we come to the step 2. What step 2 in step 2 we should do? In step 2 we should find what? First of all, we should find C bar ij, which ij does not belong to Gx. Is that okay? So the cell which does not belong to Gx is this cell, this cell, this cell, this cell, this cell, this cell. So how many C bar ij we have to calculate? 1, 2, 3, 4, 5, 6. Is that okay? 6 C bar ij we need to calculate. You remember C bar ij just calculate for ij does not belong to Gx. And so, for example, I want to calculate this C bar. And then what is it? You remember with ij belongs to, so C bar ij equal to Cij minus Ui minus Vj. Is that okay? So this number is what? We have C bar 3, 1 equal what? It's equal to 5 minus 1 minus 2. Is that okay? Then it's equal what? It is what?
It's 4.
No, 5 minus 2 minus, sorry. 5 minus 2 is 3. 3 and minus 1, then it is 4, really. Okay, thank you. It is 4. And so I delete the things I hint you. It's here. And so now, this C bar 2, 1 is equal to what? It is, tell me the number. Tell me the number. What is it?
Also 4.
4. Because it is equal to 8 minus 2 minus 2. Is that okay? Very easy. What is it number? C bar 1, 2. It is number?
It's 3.
3. Correct. Here, C bar 1, 3 is equal to what? It is 4 minus 0 minus 1. Then it is also 3. This one is so easy. What is this?
0.
That is 8 minus 6 minus 2. Then it's 0. And now there is the last one. The last one is here. The last one is here. C bar 3, 3 equal what?
The last one is 4.
4. Are there any C bar ij is negative?
No.
All the C bar ij here are greater than 0. Is that okay? Or equal 0. Greater than or equal 0. Then this BF solution is, we come to, at the step 2 here, we can come to the conclusion that the BF solution here is BF solution here is the optimal. Is that okay? That's all. So you understand? I think now you can work with the any okay, just step 1, step 2. Step 1, find out UIVJ. Find out all the UIVJ. Step 2, find out C bar IJ. If there are two cases, if all C bar IJ is positive or equal to 0, then the solution, the BF solution is optimal and we stop. If there is something like there is negative, if there's something is negative like this, it's negative here, is that okay? Somebody is negative, then this one is entering variable. And you find out the cycle, is that okay? You set up the C plus, C minus, or something like this. And then we come to step 3. Step 3, you determine this is entering variable, you step 3, and step 3 is find out the cycle C plus, C minus, and then you calculate the theta star. Okay, theta star, and in the cell plus theta star, in the cell minus theta star, and the theta star is equal to something. If theta star here is equal to xij something here, then this one is a leave-in variable. And in this case, is equal to this, and this is a leave-in variable. This leave-in, and then at the theta star here, and the plus cell plus theta, minus cell minus theta, and this becomes 0, and you updated the tree. Where is it? This one is 100 here. This becomes 0, this becomes 20, this becomes 60, 40, and then you updated the tree that this is, delete this, and then you have this. Updated the tree, and then you have the new tree here. New updated the table, and they have the new table here. That's all. I finished the iteration 2. Is that okay? And then you start the new iteration by step 1, find out UIVJ. Step 2, find out C bar IJ. And in this case, you see all the C bar IJ is greater than 0. So we stop and conclude that the optimal, this is the optimal solution. And of course, you have to write down, for example, the optimal solution is x11 is 80, x14 is 20, x22 is 100, x23 is 100, x32 is 40, x34 is 60, and all the other xij are 0. And you have to calculate, because this problem is a problem of minimum cost transshipment. So you have to calculate the minimum cost. Is that okay? And what is the minimum cost? For example, in this case, this is the solution, and what is the minimum cost? Very easy. The cost is we have the this is the optimal solution. Is that okay? That is the optimal solution. So what is the cost? So easy. Two unit for $2, for example. Suppose that is $2 of 1 unit, and $80 is 80 multiplied by 2, plus $4 for 1 unit and 100. So 100 multiplied by 4. Plus here, plus 100 multiplied by 3, plus is 20 multiplied by 6, plus here 40 multiplied by 1, plus 60 multiplied by 5. And then you have this is the minimum cost. Is it easy? Very easy. Okay. You can teach if you have some younger brother in high school. You can teach them, and then they can work very well. No problem. Okay. There's nothing special. Understand the meaning is our task. You understand the meaning why we find out theta star and why the plus cell have to add theta star and minus cell minus theta star something. The meaning of that is your task, the task of the student at the university. But the action of doing action changing like this, realizing the algorithm like that, the student in high school can do that. Is that okay? And so this topic, we study this, and the student in BA school, they also study this, but they study in another way. They teach the student learn the way how to realize the algorithm. And in our department of mathematics, I have to teach you why do we have to do that. So you need to understand. Okay? So for what? For the situation where you encounter something different, you know the way how to modify it, to apply to the new situation. Is that okay? For student of BA, no way. They just learn how to do like this, just realize the algorithm or something like this. So they don't know why you calculate theta star. They don't know why here is 20. For example, at the last time it's 20. That is 20. That is 80. That is 0. Why you put here theta star? Why here minus theta? Where is plus theta or something like this? See? Okay, it's a long time already. So we finished this. This terminates the algorithm already. So now assignment problem is there is one group talking about this one. So I don't think, but I write down very short. Assignment problem is it's a transportation problem, but there are the source and the demand and the supply. Each of the supply place is only one object, and each of the demand is only one. So for example, you have three place and 3 people, and in the company, how to arrange these 3 people to 3 position in suitable way, so that the cost is minimum. The cost means, for example, there are 3 candidates. One candidate finished the BA program. One candidate finished the financial engineering of Department of Mathematics, and one finished the EE. And there is 3 positions in some bank. Okay, and each of the no one in this is suitable. No position is really. For example, you are financial engineering, but no place for really financial engineering, something different. And so if you are assigned to this job, you need some time and some money to train you for this. And if they put you to the first position here, you also need some time and some money to train. So each of the 3 people here, to each of this one need some time and some money. Let me say some money for training. And so the problem is which one to which position, so that the cost of training is minimum. So that is one application. This the A, you have here 60, 70 or something like this. For example, you have here 100, 100, 200, 100, and here is like this. But we have here 3 and we also have here 3, nothing like this. 3, 3, and here is 1, 1, 1, and here is 1, 1, 1. 3 job, 3 people. 3 machine, 3 place. Something like that. You see? 3 machine. We have 3 machine and 3 place. How to how you say, to install the machine, which machine at which place are suitable, and the cost is minimum, something like this. So very special case of this, and one of our group will start say about this. And so now what time is it? It's 2:48. It's 2:50, and then we have a break. 2:15. Is that okay? Break. 2:15. 15. So that we have only 35 minutes. We have only 30. Sorry, today is very late. We have the 35 minutes for this, and then the group. Only one group can talk first. Is that okay? Which group I tell you last time? Which? The last time I tell you which group we talk first. Hello?
Group 2, sir.
Group 2. Group 2 with topic 1. Okay, topic 1 first. Okay, so you have a break, and after the break, anyway, the group 2 will start. Is that okay? And then if you finish, then it's okay. If you don't finish, we continue next week. Okay, have a break. Remember to come back at 15. And the group number 1 prepare things for the presentation. So I will stop recording, and then the member in the group 2, you turn on your camera. Okay. Minh Thư, Trà My, Minh Thư. Okay. So now your group, you choose one student for making presentation, and I will choose 2 or 3 more. So the first one you choose.
We choose anh Thư.
Okay, anh Thư. Let me see. Your group is here, including Trà My, Minh Quân, anh Thư, Minh Thư, and Hòa Thương. Let me see. Okay, so I choose another one is Hòa Thương, and it sounds there is only one boy. There is Minh Quân. So you ready? You can discuss together a bit, and sharing the part who will talk first or something like this. Okay. You can discuss together a bit, and Minh Quân, it seems that in your place it is a lack of light, and so you are the only boy, and but Yeah, it's too dark. People cannot see you clearly. Minh Thư is the same. Turn on the light so that people can see you. And Miss Trami, you are in the place with only you or somebody else there? Trami, I don't know why you wear a mask because maybe. Pardon?
I'm at the coffee shop, so.
You are in the coffee shop. So how can you talk? Because if there is somebody else there, then it will make noise. So why you choose that place?
This place is quite quiet, so
What fired?
it's not any trouble.
Okay, so it's okay. It depends on you. I don't. I cannot care too much thing about you.
Yeah, thank you, sir.
Okay, so who will talk first?
Me, teacher.
Your name?
My name is Anh Thư.
Okay, you answer first, and then then the two others. Who is the second?
The second is Anh Quân ạ.
Minh Quân or Anh Quân? Minh Quân. No, you have no Anh Quân. Okay. Okay, so Anh Thư first. So talk about. You can share the screen. You can share the screen and talk. It seemed to me just moment. It seemed to me just only one group sent the report and the slide to me, and the others not yet. You remember you have to send me. Is that okay? The report and the slides. You know, that's the rule. One day before the presentation, so it's okay. Not yet now, but this evening you have to send me. Okay, Anh Thư, start the group 2.
Yes, good afternoon, everyone, and welcome to our group presentation. Today, we will present about the metro water district problem, which is an application of the transportation problem provided by Method in the class. Here is a list of our group members. Quân, My, Minh Thư, Anh Thư và Thư. Our presentation will be delivered in 4 sections. We will first describe the problem in general form, then standardize it before applying the streamlined Simulink algorithm to arrive at the optimal solution. Next slide. And we first restate the standard transportation problem. Given an aim sources and end destination with corresponding supply and demands, along with the transportation costs from its sources to its destination. And the standard form assume that the total supply equal to the total demand, and we want to minimize the total allocation cost. And this power problem, as you know, can be solved with the streamlined Simulink algorithm. Our problem.
Just a moment. Until you come back, you show the. You show the. Here, there's something here. Sorry, I just move, and then I don't see what you are saying. CM1 XM1 CM2 XM2 is what? CIJ. Okay, XIJ. Okay. The supply. in the midterm test, there's somebody. Sorry, this is not the standard form. You know, what we call standard form is we should move the supply to the first column, and the demand is the first column. You know. In the midterm test, there's somebody write down in this way for the question 1. The question 1 we ask for the standard form. Standard form is not like this, but you can write down like this. In this presentation, you write down like this is okay, because in the book they write that way. Okay, continue. Anh Thư.
Our problem in consideration is about the Metro Water District Agency who wants to allocate water from the river Colombo, Sacron, Calgary to the city Purdue, Los Deville, Sengo, and Holy Cross. The information such as cost, supply, demands are given in the table on the slide. However, the problem has some key difference from the standard problem. For example, in the first one, the first one is the water supply from the Calgary to the Holy Cross is prohibited. So the transportation cost from Calgary to the Holy Cross does not exist. Also, each city has not only one demand as in the standard form, but also it has the minimum needs and the requested amount. You can see here that Purdue needs at least 30 and can receive up to 50, for instance. And we will now attempt to solve this non-standard problem. So note that although Holy Cross can receive as much as possible, in fact, the available water sources we can actually supply to the Holy Cross is limited. In this, assume that in the final optimal solution, we supply D1, D2, D3, D4 to Purdue, Los Deville, Santiago, and Holy Cross. And we can see that.
Hey, Anh Thư. You need to, I think, please come back to the previous slides and you say it again about what different here. You have need, request. Need is what and request what?
Yes, okay. We have in here that's the minimum needs and the request amount. The minimum need the water supply from the river to the city.
But minimum need means what? And the maximum or request means what?
The minimum needs is what that the city can receive.
No, not can receive.
Minimum.
Minimum need. What is the difference between the request and the minimum need?
This is the demand in the standard form.
The demand, but so the request means what? But in the book, they write down the request. They write down what in the book? They write down something different, I think.
The minimum needs is we need to supply at least that amount. The river must supply at least that amount. And the request amount that is the city request that amount.
So request that amount, but if but the all the Three River have to
I think the request amount is the maximum the city can receive. We can
but if you supply not equal to that, then there is any problem.
we supply from the, I think, just from the need to the request.
The request, it means that the minimum need. That means must.
No, the maximum. The request is the maximum. The need is the minimum.
At least that one. Is that okay? At least that number cannot be less than.
So you say you say that if we supply less than the request, right?
Yeah, the request mean.
Yes, if we supply less than the request, then this is okay. But
Sure.
Yes, less than the request is okay. It just need to more than the need. Because
in the book they don't write down request and need. You write down need and request, and it's misleading. These words are not correct. Minimum need.
Okay. It is a minimum need.
Minimum need. So that means
yes.
that you must supply at least that number.
Yes,
okay?
We must supply at least number.
And the request means I need only $5, but if you give me 10, it's okay.
Yes,
so
yes.
The minimum is 5, and the request is 10. You understand? So
understand.
if I request 10, you can supply me the minimum 5, but you can supply 6, 7, 8, 9. Okay, 10 is also okay. You understand? So
yes, teacher.
The first row is obligation.
Yes, the first row is obligation.
Okay. So
I continue.
Yeah. And you have to ask the student in the class if they understand or not.
So everyone understand?
You all the members in the class, you remember that it's the same like the presentation 1, seminar 1. Is that okay? These topics are official, and you have to understand clearly, because it may appear, I will put it appear in the final exam. If you don't understand anything in this, you have to ask the people who make presentation, the group. Is that okay? Don't understand, ask them. And you, Anthu, when you make presentation, you also have some time, stop and ask them. You understand? Is that okay? Okay.
Everyone understand?
Yes, I understand all.
So we continue the presentation. Index assume that in the final optimal solution, we supply D1, D2, D3, D4 to Purdue, Lost Devi, Sango, and Holy Grass. And we can see that D1 go from 30 to 50, D2 equal to 70, since the minimum needed is also the amount of requested water. And D3 go from 0 to 30, and D4 greater or equal than 10. And the second is the total demand should be less than or equal to the supply, which is 160.
Excuse me, until you can you tell us again? D1, D2, D3 is what? Assume that, say something there here. D is what? How to solve this non-standard problem? Okay, actually that is normal problem. It's not non-standard, but we must transfer it to the standard. But you write down something here. D1, D2. Just a moment. The total.
Yes,
you say
D1, D2, D3, D4 is the total amount of water supplied to Purdue, Lost Devil, Sango, and Holy Grass.
Oh my God! You write down like this is very hard. So come back to the. You must attack here the table so that people can D1, D2. Where is it? What is D1, D2 here? if this things D1, D2 does not go with a figure with a table, then we quite hard to imagine. D1 is what? Let the total amount. Just moment. Just a moment. You come back to the definition. People cannot follow your definition so quick like this. So let's say, see, D1 is what? Come back to the definition. D1, D2, D3. Down here. Total amount of water supplied to Purdue. This total water supply means what? You come back to the table and you tell me what is D1. Total water supply to Purdue. So mean what? Here. Just a moment. You move for the cursor outside. Purdue. Do not. You cover a lot of things. So what is the D1 here? For example, Sango, or for example, Las Davis. Lost or last? My eyes are very terrible. Lost devils. So the minimum need is 70 and the request is 70. So you call D1 is the total amount supplied to Lost Devil. So D1 is what?
Can I answer it?
Yes.
Yeah. So we recall that the Purdue we have to solve this one.
Excuse me. Somebody govern this file. Can you delete the minimum content or something like this? Just cover cover large parts of the figure, and it's quite strange. Delete this one. Minimize content or something like this. Focus on content or something. Make it disappear.
Can you see my sharing, sir?
That is okay. So D1 is what? D2 is what?
So we recall that the Purdue should, for example, Purdue should we must supply to Purdue at least 30, but not more than 50. So, for example, if we can solve this problem, then D1, which is the real amount of water that we supply to Purdue by allocating water from Colombo, Sacro, and Calgary, it must lie between 30 and 50. So I said D1 as the real amount of water that we will allocate from the Three River to Purdue after we solve the problem. And it must lies between 30 and 50 because they are the bounds provided in the problem. And D2, D3, and D4 are for the other cities.
That's understandable. But so you know, when you make presentation, you say D1, D2, D3 is a total water supply to Purdue, Lost Devil, and Sango and Holy Glass, and people cannot understand. You know, you cannot understand what is a D1. So you see, D1 is what? The real amount of water. Is that okay? The total real water amount supplied to D1 is Purdue, to Purdue. Is that okay? Then it's okay. I think that now, and you have to do not go so fast. So you ask this your friend in the class, they understand this.
Really sorry, but everyone in the class is anyone unclear about what D1 is, or D2, D3, and D4. So for Lost Devil,
So D2 is what?
D2 is the real amount of water for lost DVOs.
Yes, and it is.
Yeah, it should lie between 70 and 70, so it is exactly 70.
Yeah.
As we written here. Yeah.
Yes.
Yeah.
22.
And D3 and D4 are for Sango and Holy Grass, and so they have to satisfy the bounds. So I already write here.
D4 is greater than 10.
Yeah, so there is no upper bound for D4.
Not correct. You explain more on this, but it's not correct.
Yeah, but so initially there is no upper bound, but then after, but we will say we solve this system of equation to realize that actually there is an upper bound for D4, which is 60.
Why? Can you explain it?
Yeah, because initially in theory there is no upper bound for Holy Grass. The people at Holy Grass say that they can receive as much as they want, but in reality, because the water from the Colombo, Sacral, and Calgary, they are limited. They are not infinity. So the total amount of water supplied to Holy Grass and added up with all the cities cannot exceed this supply. So we only have this amount of water supply. We cannot give to all the city a bigger amount than this. It means that the total amount of water supplied to the 4 cities is the sum of D1, D2, D3, and D4. It must less than or equal to the available supply, which is 160. And then we use the inequalities, and we will have that. So the second inequality implies that D4 is less than or equal to 160 minus D1 minus D2 minus D3. But D1 is greater than or equal to 30. So minus D1 is less than or equal to minus 30. And similar, D2 is exactly 70. And D3 is greater than or equal to 0. So minus D3 is less than or equal to minus 0. And this right-hand side equal to 60. So we derive upper bound for D4, which is 60.
Just a moment. D1 greater than 30, then minus D1 less than minus 30. This is the expression here. The expression here is it looks like, for example, D1 greater than 30 but less than 50. So why you choose only one greater than 30 to apply here? You forget the second inequality. Why?
We do not forget because we only want to find the upper bound for D4 only. The fact that 30 is less than or equal to D1 will be included in the problem later on. But up to now, we only need to find an upper bound for D4. So we want to make sure that the inequality is the less than or equal to sign. So we have to use the first part of this.
The explanation sounds very very mathematical, but in practice it's much easier. There is a much easier way to explain. So, and other in the group 2 can have another explanation for the bound of D4.
Can I re-explain it in another way?
Yes.
So we know that D1, so we must apply to Berdue at least 30. Yeah. we have to supply to loss level at least 70.
Yes.
And we have to, of course, we have to supply to Sungo at least 0.
0.
So it means that for the first 3 cities here, we have to supply to them a total of at least 100. So we sum up the 3 number here, so we have 100. For the first 3 cities, we have to use at least 100 to supply to them to meet their minimum needs.
Yeah, that's easier to understand. Is that okay? The minimum need of all the 3 is only 100. So in the best case, that means in the nicest case, is that okay? That's all the other are supplied with the minimum need. Then the total is for the last one. Is that okay? All the other water out of for the last one is what is that? The last one is
Holy Grass.
A holy glass. They suppose that all the other obtain the list, then the total less for the holy glass, then it's also just only 60, because the total is 160. Is that okay? And the least of the 3 is 100. Then the maximum holy glass can receive maximum is 60. Is that okay? It's much easier to understand than you do the mathematics like a mathematician. Is that okay? The other in the class, you understand? You have something to ask the group presentation now at the moment?
Yes, now I understand, teacher.
Pardon?
I
You
got
said-
it. I got it. Yes, I got it.
Okay, you tell to the people there. So now continue. I don't know, Anh Quân or Minh Quân, Anh Thư or Minh Quân will continue.
I will continue.
Suggesting you the table presented here. Note that the total supply is 160, while the total demand is 210. So we need to add a dummy resources with 50.
Just moment. In this case, so why you choose the demand is the maximum? You choose the demand is the maximum. Why?
Because we are tend to use them as a destination demands and include the lower bound concentrator. The upper bound is 50, 70, 30, and 60.
Minh Quân, can you explain it in another way? So why do you use the demand? The demand is the maximum need, not the minimum. For example, holy glass, you write out 60, and Sengo is 30. I don't have the you come back to the previous table here. So you use the last one, is that right? You use the last row request. 50,
Yeah,
70, 30, and here is 60. Is that okay?
Yeah.
So why? Have any reason for this?
It's because for this problem, we have 2 different types of demand for each city, the need, the minimum need, and the maximum request. it is different from the original problem. In the original problem, each destination only have one demand. So
Yes.
between so we have to, so we'll determine that we will choose one of them. Say that we choose the request, and then as the initial demand for the streamlined simplex method to work, and then we will try to include the lower bound constraint later on. So after we set the upper bound as the demand, then we will include the lower bound constraint in the problem and modify it. So the final its final form will satisfy both upper bound and lower bound.
But if you include this one, okay, now time is almost over. So let me, we stop here, and then okay, you stop here, and then next week we continue. But let me explain to you some minutes. That is the time. Let me show you just a moment. Let me make a photo of this. You come back to the previous figure. Here, just stop. Okay, so the group 2 stop here. Is that okay? And I will tell you something. Why you have to take the second row. The idea inside. Is that okay? Now I will share the screen so you can. Also, because if I want to express to explain to you, then it takes a lot of time. I think it's at least 15 minutes. So now, like this, the group 2, you come back and try to think of why do you choose the maximum. You transfer to the normal problem. Is that okay? You have 2 needs, minimum need and maximum. Is that okay? And then you transfer to the normal transportation problem. There is only one demand, and here I have 2, and they choose the second row. See? And the question you have to think in your mind, why? If you use the first one, then what happened? You see? If we think of it, if you choose the third row, the first row, the minimum need, then maybe there are some extra water. Is that okay? There's some extra water, and then we need to distribute it to some other which is needed. But if you use the maximum, then not enough water. Is that okay? The minimum is okay, but the maximum is not enough water. Then how can we do in that case? Is that okay? And you have the way you do like this, and then you choose the maximum. Okay? Okay. Think of it. And next week, the group 2 continue. And the other group also start with the language. Okay? Very sorry. Today you have so little time. Okay? Bye-bye. And remember, today there is you know today what there is something happened today, you know? No? Today is the first day of the SEA Games. Is that okay? And the first match is very interesting match of the Vietnam football team and the one of Indonesia and
Yes,
Vietnam.
it's 7 p.m. teacher. Yeah, 7 p.m.
I don't know exactly the time. I will say, but you
7
you
p.m. Yes.
7.
Yes, Vietnam versus Indonesia.
Yeah, that's a very interesting match. I think
Yeah.
you should. The last SEA game, Indonesia and Vietnam come to the final. Is that okay? And now we meet them at the first match. Indonesia now is become very strong. So it's very interesting. Okay, see you.
Goodbye, sir.
So bye-bye. I'm leaving. So okay, see you next week.